So, question 1. Write 36 as a product of its prime factors. Start with 36 and think of two numbers that multiply to make 36. It's 2 and 18. 2 is a prime number, so I'm going to circle it. Two numbers that multiply to make 18, 2 and 9. 2 is a prime number, I'm going to circle it. Two numbers that multiply to make 9, 3 and 3. So your answer would be 2 squared multiplied by 3 squared. Make sure you get the multiply. So, question 2. Kira is 7 years older than Jay. Martha is twice as old as Kira. The sum of their three ages is 77. Find the ratio of Jay's age to Kira's age to Martha's age. Now the ratio, leave that till last. Let's work out what the ages are first. J seems to be the root of it all, so I'm going to say that J is X years old. I don't know how old he is, but I do know that Kira is 7 years older. So Kira is 7 years older, X plus 7. Martha is twice as old as Kira. Martha is twice as old, so that's 2 lots of X plus 7. Now Martha then is 2X plus 14, if I expand that. And it said the sum of their three ages is 77. So 77 equals X plus 7, Kira's age and Jay's age, plus 2X plus 14. Simplifying that, give me 77 equals X plus 2X is 4X. 7 add 14 is 21. Subtract 21 from both sides. And I get 4X. And I get 56. 56 is 4X. Divide both sides by 4. 4's into 56, 4's into 1 and 5, go once, 1 left over, 4's into it, go 4 times, 14. So we know X equals 14. That was Jay's age. Now it says find the ratio of Jay's age, Jay's first, Jay is 14, to Kira's age. Kira was 7 years older. 14 plus 7 gives me 21. To Martha's age. Now Martha was twice as old as Kira, so twice 21 times 2 be 42. Quick check, 42 add 21 would be 63, add 14, 77. 4 marks. So, question 3. ABCD is a parallelogram. EDC is on a straight line, EDC. F is a point on AD, so that BFE is a straight line. Angle EFD is 35, EFD, so that angle there is 35. DCB is 75, DCB, that angle there is 75. Show that angle ABF is 70. ABF, that's this angle. That's the angle we need to find. First thing I've noticed is that angle and that angle are vertically opposite, so that's 35 degrees. Now it does say give a reason for each stage you're working. AFB equals 35 degrees because vertically opposite angles are equal. The next thing I can see is that this angle here is 75, so this angle here must be 105. I know that because supplementary angles, both parallel lines there, add up to 180 degrees. So angle FDC equals 105 degrees because supplementary angles add up to 180 degrees. Now if that's supplementary, that must be supplementary, so that is 75 degrees. AB equals 75 degrees. Same reason. Therefore, we've now got a triangle. 180 minus 75 plus 35 equals x. Angles in a triangle add up to 180 degrees. So let's just work this out now. 75 add 35 is 110. 180 minus 110 will give you 70. X equals 70 degrees. Proved. So, question 4. The diagram shows a logo made from 3 circles. Each circle has a centre 0. Daisy says that exactly 1/3 of the logo is shaded. Is Daisy correct? You must show you're working. So, the shaded logo is a circle with a radius of 7 centimetres, but with this bit taken out of it. So I'm going to work the 7 centimetre one out first. Area of a circle is pi r squared. Pi times 7 squared would be pi times 49. Now we can write that as 49 pi. The other circles, we've got this one here. Let's put it over here. Pi times 4 squared equals, well, 4 squared is 16 times pi, 16 pi. And the other one we've got 4 add 3 is 10. Pi times 10 squared, which would be 100. 10 squared is 100 pi. So they're all my areas of all 3 circles. Now remember, the shaded circle was the radius of 7, take away the radius of 4 one. So the radius of 7, so shaded, we've got 49 pi, the radius of 7 one, minus that one, 16 pi. Now the same rules apply from like algebra. 49 take away the 16. So that would leave you with 33 pi. And that is the area in terms of pi of the shaded circle. Non-shaded made up of 2 parts. This part and this part. Now remember, this big circle originally had a radius of 10. So the big circle was at 100 pi, that one. And actually we don't want that bit. So we've already worked out what that shaded bit was. That was 33. Take away the 33 pi. 100 pi, so that would give you 100, take away the 33, 67 pi. Now, Daisy says that 1/3 of the logo is shaded. Shaded is 33 pi. Not shaded is 67 pi. But it's 33 pi out of 100 pi. That's the whole lot, isn't it? 33 pi out of 100 pi. 2 pi's cancel out. 33 over 100, which is 33%. Is that the same as 1/3? No. 1/3 is 33.3 recurring percent, remember. Daisy is wrong. First bit of the sentence. We have calculated that the shaded area is 33% and she said it was 1/3, which would be 33.3%. Question 5. Table shows the information about weekly earnings of 20 people who work in a shop. Work out an estimate for the mean of the weekly earnings. Now I'm going to start with mean is the total divided by the quantity, the number of people involved. So we need to work out the total earnings. Now we know this one person earns between 150 and 250. So I'm going to put them down for about 200. These 11 people earn between 250 and 350. So I'm going to go for about 300. I'm finding the midpoints of each of these. 400, 500, 600. Now as I said, this one person earns about 200. So they earn 200 pounds. Now these 11 people earn 300 each. So that's about 3,000 from 300. 5 people earn 400 each, so that's about 2,000. All I'm doing is multiplying all of these. 0 times 500, that's an easy one, 0. 3 times 600 is 1,800. And now I need to add them up. 0, 0, 0, 0. Easier if you kept them in a straight line, 0, 0, 0. 2 add 3 is 5, add the 8 is 13, 3 add 2 is 5, add the 1, 6, add the 1, 7. 7,300. Now that's the total earnings. As we say, that's the total earnings, we need to divide it by the quantity. Now I could do that two ways. 1 add 11, add 5, add 3. 20, which incidentally is the same 20 people it mentioned earlier in the question. So 7,300 divided by 20. Now remember it is non-calculator. I'm going to take noughts off from each one. So I've got 730 divided by 2. 2's into 7, 3, 0. 2's into 7 go 3 times, 1 left over. 2's into 3 go 6 times, 1 left over. 2's into 10 go 5. The answer is 365. 3 marks. The next part of the question says, Nadia says, the mean may not be the best average to use to represent this information. Do you agree with Nadia? You must justify your answer. Now when you look at the data, you could say the majority of people earn their wages around this area, between sort of the 300 and 400 mark. Now we're saying that 365 is the top one, is the average. Now, but the majority of people earn about 300. So you could argue that this is skewed due to these high earners up here. That's pulling the average up. Okay. So do you agree with Nadia? It's up to you. You could say yes, you do agree, or no, you don't agree, but you need to justify your answer. I'm going to say that I don't agree. I do not agree. As the modal amount would be about 250 to 350, which is close to the mean. You could have said, I do agree that Nadia says so, the mean is not the best average, and you would use the modal average, or you'd use the median, and you would talk about the fact that these high earners pull up the mean amount. Question 6. Here is a rectangle. All measurements are in centimetres. The area of the rectangle is 48 centimetres squared. Show that y equals 3. So we know that's where we're aiming for. We're trying to work out what y is. And y is up here. Now the first thing I see is this word area. Area of a rectangle. And I know that's base times height, or length times width. Well, that's the length of it, or the width of it there is y. So it's going to be y multiplied by one of these. Now it doesn't matter which one they are, but I've noticed that they're both different. I'm going to say it's y times 2x plus 6. I've done it in brackets because it's that whole thing that y is multiplied by. I don't know what x is, but I do know it all equals 48 centimetres squared as the area. Now I notice that these two are different. Well, on a rectangle, these two sides are the same length. So I know that 2x plus 6 must equal 5x minus 9. If I know that, then I could add 9 to both sides. And I'd get 2x plus 15 equals 5x. Subtract the 2x from both sides. I'd get 15 equals 3x. Divide both by 3. And I would get 5 equals x. I can now use that information over here. Y times 2 lots of 5 plus 6 equals 48. Y times 10 plus 6 equals 48. Y times 16 equals 48. Divide both sides by 16, divide by 16, y equals 3. I have proved it, 4 marks. Question 7. Brogan needs to draw the graph of y equals x squared plus 1. Here is her graph. I'm drawing the graph there. Write down that's one thing that's wrong with the graph. I can see straight away she's gone dot to dot, dot to dot, dot to dot. The graph needs to be drawn with a smooth curve. And we're done. 1 mark. Question 8. Write these numbers in order of size. Start with the smallest number. Now I can see they're all decimals and some are recurring decimals. So I'm going to write them out as they would be if they were recurring. 0.246. Now these dots are the start and end of the recurring, so that's 46. And it will keep going 4646. This one's 0.246666, just one dot over the 6. This one is 0.246, 2 dots though, so 246. And that's how that one's going to keep repeating. And the last one is just 2.46, no dots, no recurring. Now I know each of these numbers all start with the 0.246, but if I look at the next digit, this digit here, this digit here, this digit here, and this digit here. Oh, there isn't one here, I'll put a 0. I can now see that that one is the smallest, followed by that one, followed by that one, followed by that one. But I'm going to write the original numbers down. Now that was the smallest one, so 0.246. The next one was that one, 0.246 with a dot there and a dot there. Then it's that one, 0.246 with a dot there and a dot there. And finally 0.246 with one dot there. There we go, 2 marks. Question 9. James and Peter cycled along the same 50-kilometre route. James took 2.5 hours to cycle the 50 kilometres. Peter started to cycle 5 minutes after James started to cycle. Peter caught up with James after they both cycled 15 kilometres. James and Peter both cycled at constant speeds. Work out Peter's speed. Now it says work out Peter's speed. And I've got here, I know that speed, distance, time. To work out speed, I need distance and time. And I've actually got here, James did 2.5 hours to cycle 50 kilometres. So let's work out James's speed. 2.5 hours, 50 kilometres. Speed is distance divided by time. So 50 kilometres divided by 2.5 hours. Now I don't like dividing by decimals at the best of times, so I'm just going to use equivalent fractions here, multiply both bits by 2. 5 hours, 100 kilometres. 100 divided by 5 is 20 kilometres per hour. I know that James's speed was 20 kilometres an hour. Now it says that Peter caught up with James when they both cycled 15 kilometres. So I want to know really how long it took James to cycle 15 kilometres. I know his speed is 20. I know his distance is 15 kilometres. So let's work out his time. Distance divided by speed. James's time to do 15 km. (15 kilometres divided by 20 kilometres per hour). 15 divided by 20. Oh, that's quite hard. Well, what about simplifying it? 3/4. That's 3/4 of an hour. 45 minutes if you wanted to do it in minutes. It says up here that Peter started to cycle 5 minutes after James. So Peter took 40 minutes to cycle 15 kilometres. I've got my distance, I've got my time, just need to work out the speed. Now 40 minutes in hours would be what? Well, that's 40 out of 60 minutes. 40 out of 60 minutes, I could say that's 2/3. Now I would make that down to 2/3. But I've still got to work out, speed is distance divided by time. Distance is 15 kilometres, time is 2/3 of an hour. Let's leave it like that, 2/3 of an hour. So, distance, 15, divided by 2/3. I'm dividing fractions. Now remember, when you divide fractions, you keep it, you kiss it, you flip it. But that's not a fraction, so I'm going to turn it into a fraction. It represents 15 whole ones, 15 over 1. I could now write 15 over 1 multiplied by, keep it, kiss it, flip that, 3 over 2. 15 times 3 would be 45, divided by 2. 45 divided by 2 would be 22.5. The final answer is 22.5 kilometres per hour. Okay, question 10. 10 to the power of a half. Anything to the power of a half is a square root. Square root of 100 is 10. Done. Find the value of 125 to the power of 2/3. That's the cube root of 125 and then squared. Cube root of 125 is 5, and square that would give you 25. 2 marks. So question 11. The first thing I look at, 3 teas and 2 coffees have a total cost of £7.80. 5 teas and 4 coffees have a total cost of £14.20. I'm going to write them out so they're equations. 3t plus 2c equals 7.8. 5t plus 4c equals 14.2. Now looking at those two equations, I can see that I've got 2 c's here and 4 c's here. Now if I make these the same by multiplying this top one by 2, and you could say that one by 1, I'm going to have the same amount of coffees. That whole equation times 2. 6t plus 4c equals 7.8 times 2. 78 times 2. 2 8 16. 7 2s are 14. Add the 1, 15. 15.6. Don't forget to put the decimal back in. 5t plus 4c equals 14.2. Same side subtract, different sign add. We've got the same sign, we're going to subtract those two equations. 6t take 5t would leave t. 4c take away 4c would just cancel out. So we're going to do 15.6 take away 14.2, which would leave you with 0.8. That wouldn't, it would be 1.8. 6, take away the 2, ignore me completely. 15.6 take away 14.2. 6 take away 2 is 4, decimal point. 5 take away 4 is 1. T equals 1.4. T is £1.40. I'm now going to use that information to work out what the coffee is. I'll use this top equation. 3t plus 2c equals 7.8. 3 lots of 1.4 plus 2c equals 7.8. 1.4 times 3. 4 times 3 is 12. 1 times 3 is 3. Add that is 4. 4.2. 4.2 plus 2c equals 7.8. Take away the 4.2. Take away the 4.2. 7.8 take away 4.2. 8 take away 2 is 6. 7 take away 4 is 3. 2c equals 3.6. Divide both of them by 2. 1 coffee would be 1.8. £1.80 for a coffee. 4 marks. Table shows information about heights in centimetres of a group of Year 11 girls. Least height 154, median 165, lower quartile 161, interquartile range 7, range 20. Now it's important to remember that your least height, that's going to be your smallest one, so I'm going to count up here, just checking it goes up 1, 2, 3, 4, 5, 6, 7, 8, 9, yep, in tens, so 154 would be here. That would be my 154. Median 165. So 165, just going to put in that line there. Lower quartile 161. Right, put that line in there. Interquartile range. So it hasn't said the upper quartile, it's told me the range between the lower quartile going up. 161 was the lower quartile. It's going up 7 more, so I'm looking for 168. And there we go. And finally the range, so that's 20. The least height was 154. Add on 20 would be 174. And join them up. And there we go, 3 marks. The next question, after we've drawn the box plot, asks you to compare the heights of Year 7 girls with the distribution of heights of the Year 11 girls. Now whenever you're comparing box plots, you're looking for 2 things, and there's 2 marks available, one for each of these. First thing you're looking for is to compare the median, and then you want to compare the spread or the range. Now you could compare the range or the interquartile range. Doesn't matter which one, as long as it's one of those measures of spread. So I'm going to put the IQR. First comment. The median for the Year 11 girls is 165, which is higher than the median of the Year 7 girls at 151, 2, 3, 4, 5, 6, 7, 7.5, 157.5 centimetres. Make sure we've got the units on. Next I'm going to talk about the interquartile range. The interquartile range for Year 11 is 7 centimetres, which is, now I haven't actually counted it yet, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and a half. Smaller than Year 7, which is 10.5 centimetres. And there we go, the two sentences. Median for the Year 11 girls is 165 centimetres, which is higher than the median of the Year 7 girls at 157.5 centimetres. The interquartile range for Year 11 is 7 centimetres, which is smaller than the Year 7, which is 10.5. That means that there's less of a spread of the Year 11s. The Year 7s are more spread out. You could also have mentioned the range. You could have talked about the range instead, where the range for the Year 11s is 20 and the range for the Year 7s is 24.5. So again, there's a bigger spread of the Year 7s. Question 13. The factory makes 450 pies each day. The pies are chicken pies or steak pies. Each day, Milo takes a sample of 15 pies to check. The proportion of the pies in his sample the proportion of the pies in his sample that are chicken is the same as the proportion of the pies made that day that are chicken. On Monday, Milo calculated he needed exactly 4 chicken pies in his sample. Work out the total number of chicken pies that were made on Monday. Now, he had 15 pies, and that represented a proportion of 450 pies. So I'm looking at what you do to 15 to make 450. Well, 15 times 30 makes 450. So if you had 4 chicken pies and multiplied that by 30, you should end up with 120 chicken. 120 chicken pies. Keeping it in proportion. They're both multiplied by 30. On Tuesday, the number of steak pies Milo needs in his sample is 6, correct to the nearest whole number. Milo takes a random pie from 450 pies made on Tuesday. Work out the lower bound of the probability that the pie is a steak pie. 6, the lower bound of 6 would be 5.5. Now we already know that he's multiplying it by 30. So you could say 5.5 multiplied by 30, and we'll work it out like that. 5.5 multiplied, now I'm going to times that by 10 to make it a whole number. 55 times 30. 55 times 30 would be, let's work it out like this. 5 times 0 is 0, 5 times 0 is 0. 5 times 3 is 15. 5 times 3 is 15, carry the 1. And divide it by 10 to get it back to there. I've got 165 steak pies. And that is out of the 450 pies. Out of 450. Now remember, probability can be written as a fraction. 165 out of 450. Done. Now we're starting to get into the realm of some really hard questions. The last ones, 13 and 14, 14 and 15, we haven't done anything similar to that, so I'm going to leave them for now and we'll come back to them later. y is directly proportional to the root 3 of x. If you just write y equals, if it says directly proportional, that means k times, and then write that out, that is 1 mark. Y is k times root 3 of x. Done. 1 mark. To get the next mark, we actually need to put these numbers in. 1 and 1/6 equals k times root 3 of 8. Root 3 of 8 is 2, so it's k times 2. 1 and 1/6 is k times 2. Divide both sides by 2. Means that 1 and 1/6 divided by 2 equals k. Now this can be quite tricky to actually work out, so I'm going to first make it into a top heavy fraction. 7 over 6 divided by 2. Now 2 is a whole number, so I can write it as 2 over 1 without changing it. 7 over 6 divided by 2 over 1. Keep it, kiss it, flip it. 7 over 6 times 1 over 2 comes to 7 over 12. And that is what k equals. That is another mark. Now, it says find the value of y when x equals 64. Y equals 7 over 12, I'm using this formula here. K I know is 7 over 12, times root 3 of 64. Root 3 of 64, y equals 7 over 12 times 4. Again, I've got a fraction, and the fraction I'm multiplying. 4 is a whole number, 4 over 1 I can write it as. Y equals 7 times 4, which is 28. 12 times 1, which is 12. Y equals 28 over 12. Now you can leave it like that, and actually you'd get all 3 marks there. But if I break it down, I could get 14 over 6, 7 over 3. Y equals 7 over 3. Now, I'm not expecting you to get full marks on that, but you can see the processes we've gone through. 1 mark for putting that down. Substituting the numbers in and working it through, we can get to that answer. Substituting that answer into that original formula, we can work it out and we can work it through to get that. Now with question 17, we've done nothing like this again, but let's try it. It says n is an integer and whole number. Prove algebraically that the sum of this and this is always a square number. Now I look at this and I see a single bracket with something outside. I could multiply that. A half n times n would be 1/2 n squared. A half n times 1 would be a half n. Now just doing that gets you 1 mark. Let's expand this one as well. I've got 2 brackets here, so I'm going to use FOIL. N times n would give me n squared. So first outside, n times 2, 2n. The inside ones, n, 1 times 2, 2. Now remember, there's a half outside it, so I'm just going to put brackets there, put that half back there. Simplifying this down would be a half n squared plus 3n plus 2. And that means a half times all of that. A half times n squared would be a half n squared. Half times 3n would be 1.5 n. And a half times 2 would be 1. Now it did say up here, the sum. I'm going to add that and that together. A half n squared, add another half n squared, would be an n squared. Half n, add 1.5 n, would be 2n. And finally, the plus 1. Now it asked me to prove that it's always a square number, and I've ended up with n squared plus 2n plus 1. Well, that doesn't shout to me that it's a square number. So I think, well, what does a square number look like? What could I do with that maybe? Well, I could factorise it. I could put it in brackets. I've got an n in both of them. Two numbers that multiply to make 1. Well, it's 1 and 1. And 1 add 1 makes 2. Add 1, add 1. I've got the same thing in both brackets. It is squared. And that is my algebraic proof. Now, it all started because I tried doing some of these stuff. Now, question 18 says, enlarge shape P by scale factor -1/2 with centre of enlargement 0, 0. Label your image Q. So I'm going to move it down. I'm going to find my centre of enlargement. That's here. I'm just going to label these corners of this shape. I'm going to label them A, B, C. Now the vector I would have to move to get from here to here would be 2 right, 3 up. The vector for that would be 2 right, 3 up. There we go. But it said the scale factor was -1/2. Multiplied by -1/2. So half of 2 is 1 and a minus, so it's -1. Half of 3 is 1.5 and a minus. So that's the vector for my new A. I'm going to move 1 this way and I'm going to move 1.5 down. There, that's my new point A. I'm going to repeat it for point B. Vector would be 1, 2, 3, 4. And it would be 1, 2, 3 up. 4, 3. Times -1.5. half of 4 is 2. So that's a -2. It's a minus. Half of 3 is 1.5. It's a -1.5. So my new vector there is going to be 1, 2 across, 1.5 down. There's my B. Finally, C. My vector to get to point C would be 1, 2 across, 1, 2, 3, 4, 5, 6, 7. 2 across, 7. Times -1.5. Oh, -1/2, sorry. Half of 2 is 1, with a minus, -1. 7 times 1/2 is 3.5, -3.5. So let's put that on this diagram here. From 0, I'm moving 1 along. 1 to the left. I'm moving 1, 2, 3.5 down. And that's point C. Join up the 3 points. And I've got shape Q.